All right, let's go ahead, move on to the part 2 of lesson 2. We will go ahead, flip the notes to the second page. So what we are seeing in the example 3 is that it says find two functions f and g such that h of x is f of g of x. So it's kind of long and confusing. So let me break it down for you so they can see better. Okay. So, well, first, again, to see this better, we can say f of g of x. Okay, so the outer function will be the f function and the inner function will be the g function. So what we're saying is that we have a function called h, and this h, it's actually a combination of f and g inside the f. So just like any other math topics, we say, all right, now you know how to walk forward. Let's learn how to walk backward. Okay, so you know how to put functions together. Now, can you break them apart? Can you break them apart? So I'm going to give you maybe like 20 seconds. Okay, you can pause the video right now and then check if you understand the inner function and outer function. Now, so we're going to look at this and we say, hey, can you spot out the inner function and outer function? I'm going to switch back to the color coding earlier. Okay, so that you can see better. So we say, hey, everybody, can you go ahead and propose what's f of x and propose what is g of x? Okay, go ahead and think about it. Okay, and then when you're ready, just go ahead, click resume, okay, click play, and then we can continue to go over this particular question. All right, so what do we have? Now, I think the inner function is pretty easy to spot because you've got some help. So what's the inner function? What's the g of x? Well, if you know what's going on, this is the g of x. This is the g of x. That's the inner function. So I'm going to highlight it so that you can see what's going on. So I'm going to highlight this. So so this is the g of x, okay? Because it looks like this is one single entity. And what's the outside? Well, the outside is going to be this part right here. Okay. So what is the notation for f of x? And we say, oh, the notation for f of x is going to be x cubed. Because we can clearly see that it seems like the 5x plus 2 is being dumped into the place of the x value for f function. So that's how we say, oh, yeah, I can see this fairly easily. The inner function is 5x plus 2. That's g, and the outer function it's x cubed. Now, again, I promise you, you will see a lot of this in calculus. So just make sure that you have this proficiency to tell the inner function and outer function. All right, so let's move ahead to the final example. Example 4, we say that the number of bacteria n, okay, so number n of bacteria in a refrigerated food, it's given by n of capital T equals to 20t squared minus 80t plus 500. Okay, and the capital T is in degrees Celsius. So what we're saying here, based on the first sentence, is that we are anticipating some counts of bacteria, and this count behaves the function, the quadratic function, because you see the t square, so it's very similar to the quadratic function. And now we're saying, hey guys, so we have a function right here up there that is to describe the relationship between n, the number of bacteria, and the capital T, the temperature. Now, next up, we say when food is removed from the refrigerator, the temperature of the food is going to, well, increase, right? If you remove food from the refrigerator and place it on a tabletop, the temperature is going to go up. And if the temperature is going to go up, we can actually describe what it is. So we say, oh yeah, big T of T, okay, the small t is the time. So we say it's equal to 4 times small t plus 2, meaning that so you have some hours, and it also provides a domain restriction that is it has to be between 0 and 3. That's the domain. Okay, that's the domain of the small t. So we say, yeah, we're just observing the sample from 0 hour to 3 hours. So Okay, so that's the function. It's a linear function. We expect everybody to understand that, oh yeah, as time goes on, the temperature gets warmer since it has a positive slope. So let's go ahead and look at part A. I think you can do this. So why don't you go ahead and do this, okay, on your own? And I'm going to write down mine right here. So n of t, please make sure that you write this down on your own paper. Okay, do not skip this part because we need to tell people what we are writing, So we say, oh yeah, so inside the function n, all the unknowns inside the function n is going to be replaced by another function, the big T of t. So we say, oh yeah, so 20 and then parentheses square minus 80 and then parentheses again, and then plus 500. And what do we place inside the function right here? I'm going to color code this. You can see it better. So we say, oh yeah, we're going to put in big T of t function. We say, oh yeah, so that there you go. You have 4t plus 2, and then 4t plus 2 here. Okay. So we ask the question, are we done? Can we just leave it like this? Well, the decision making is based on how likely you will see some like terms that could be combined. If you see it, go ahead and combine them. Okay. If you see them, they are going to appear, then so do whatever you do. We'll do whatever you need to do to make the simplification happen. We say, oh yeah, let's go ahead and think about the foiling. So we say, oh yeah, that's equal to 16t plus 16t squared, 16t squared, and then 16t plus 4. Okay. Minus, you can actually go ahead and distribute this to just to save time. 320t minus 160 plus 500. Okay. So we say, hey, we can go ahead and break the other set of parentheses too. So we say 20 times 16 is 320. 320t squared plus 320t plus 80. And then keep writing the remaining stuff, 320 minus 320t. And then we can combine negative 160 and 500 together. That becomes positive 340. Do we have any more like terms to combine? We say, oh yeah, of course. Plus 320t minus 320t. That's sweet. We can actually break them apart. And we have also two numbers right here. We can also combine them. So the final answer is going to be 320t squared plus 420. So that's our big N of big T of small t. Okay. So what does it do then? So originally, this is based on the temperature. It's not related to time. So what we can do now is that, well, since the number of bacteria depends on the temperature and temperature depends on time, let's just put the time into the function of bacteria. So N of big T of t simply means the number of bacteria, okay, at time t. Okay, so if you have time, you can actually go ahead and find out the amount of bacteria that you store in food. Okay, and let's just do a little thought experiment right here with this notation. Okay, that's big N of capital T of t. So we say, all right, so based on this, if time is equal to 0, at the very first moment, do we have any bacteria? Okay, at the very first moment, when t is equal to 0, do we have any bacteria? And we say, oh yeah. Because if t is equal to 0, then this part is 0, but it doesn't affect the 420. So we say, yeah, the initial amount for the big N of capital T of small t, it is equal to 420. Okay, that's what we have when it starts off, and that's how it keeps on growing. And with this equation, we say, oh, you know what? We can now substitute the x with 1.7. So we say, oh yeah, 1.7 right here in the place of x. I'm sorry, my bad, not x, it should be t. Okay, it should be t, there's no x right here, it's t. So, so 1.7 will be the value of small t. And we say, oh yeah, so this is 320 times 1.7 squared plus 420. Okay, so go ahead and calculate. And I believe if you calculate it, okay, you may want to use a calculator to calculate this. It will turn out to be 1344.8. 1344.8. Now, is that our answer? Well, we are trying to find out the number of bacteria, and you can't really have 0.8 of a bacteria, 0.8 of a bacteria. Well, no, like if you want to describe this, maybe the bacteria is reproducing. So that's the other one, the 145th bacteria that's about to be born. Okay. So in order to describe the number of bacteria, then we will say the number of bacteria is actually 1344. Okay, we round down because we don't have the 1345th one just yet. Okay, so it's very straightforward. Okay, it's nothing really new. Okay, the operation, it's something that we have done already. It's just that now instead of giving you the actual expression, we just say arbitrarily, that's the g of x, and then you have to get the those g of x or f of x inside the function. Make sure you can tell the inner function and outer function. But that's it. That's really it for the part 2. So when you do your worksheet, please do make sure that you have great notation. Don't forget to write the equal sign whenever you are trying to substitute. Make sure that's a gigantic pair of the parentheses so that it wraps around the new x value. Okay, and when you have the new x value, then we can say, oh, I can see what's going on here. I can see what's going on. Okay. So that's it. So work hard on the worksheet, and we'll talk to you again very soon.